coming to the last part, the products, right? So with heterogeneous architecture and enterprises requiring their data to be analyzed, their business critical data to be analyzed locally. So there will be edge servers, and they will require their AI algorithm specific, domain specific accelerators to be attached to the x86 kind of edge server, right? So like Naveen was talking about, he's building a modular TV, right? So edge server, yeah. So it's like you have a main CPU, and then you want to have acceleration, and you can have accelerator closer to the CPU attached using the CXL, right? So you will see a lot of domain specific accelerators coming up, right? And the AI PC kind of use cases, right, where AI reaches to the mass population, and then we talk about huge power consumption in AI training at the data center, and it's causing a lot of greenhouse gas emissions, right? So it will require a lot of innovations there to do the AI training at efficiently. But we cannot ignore the AI inference, because as the AI reaches mass population, and then inference would be done more frequently in millions of AI devices. So that will remain another critical factor to look into for innovating, right? The AI PC NPU performance need, or the performance demand, will keep growing, and that too at reduced power, right? So I see there is a bright future. Basically, we have so many exciting things coming up, and in the longer term, if you see, to meet the compute performance demand, we may see a lot of progress on quantum computing, and quantum computing integration with the traditional semiconductor, right? And we may see like novel architectures like neuromorphic computing, the brain inspired computing architectures coming, or getting commercialized, and non-conventional architectures coming up in next decade or so.
Got it. That is, you know, kind of where, we are seeing a universe where every item that we use is a computer in itself, which is all kind of connected. And then, so I see that happening in a very, very, low latent level right now. But I believe, there'll be a, like everything, right from your, even your gas stove, air fryer to washing machine, dishwasher, everything connected. And then, you switch it, turn it on, turn it off from wherever you are. It's happening today. But then, when you talk about, industry specific accelerators added to these chips, probably this will, kind of make IoT the future of it, I believe. And Harshad, coming back to you, now all these things are connected, networked. So where do you see, Juniper growing and, ensuring that all these networking things are covered?
Right. So Deepak covered a lot of good points. So I'll talk only about the connectivity part. We are seeing 5G already, right? Because when we say all these devices are going to be connected, they're mostly going to be through 5G, and 5G is not going to be enough. So we are going to 6G, and that will enable the concept which we don't have today, with the 6G standard working on, is to give a very good latency behavior on a telecom network. Now, this all is going to put a lot of challenges on the edge routers and the core routers of the service providers. So I see a lot of innovation happening there, newer devices coming there, which could be enabling these services. Something like any virtual game you want to participate, and you are doing on a 5G or a 6G network, the latency becomes critical, and it becomes critical, and it's tuned across the network. So it's not only about your connection. The other part which Raghu just mentioned once is the co-packaged optics. It may happen, it may not happen. So the industry is trying to figuring that out, because when so many 6G connection comes in, the capacity of the router also has to grow by 10x. So how do you connect all these chips at such a high rate? Third part Deepak talked about is how do you cool these things, right? And people are already talking about immersion cooling, right? We are only doing air cooling today, and that is not sufficient. Uh, People are even talking of breaking a box, a traditional chassis into a distributed chassis. So a lot of ideas people are trying. This would evolve into more complex system getting built, because now your approach will change if you break it out just to cool it, because someone may not be very comfortable with immersion cooling, because then you have to put a new infrastructure for doing that. So next decade, compute and network both are going to grow, because it's not no more only the Western world using the compute, right? It's all the Indians, Chinese. So the amount of data which is going to come into the networks, getting routed, getting used, it's just going to explode more and more, because now people are onto it, right? So they're going to build more use cases. So this is going to grow to a 2x, 4x level in next decade very easily. So we all have to be geared up for it, and we are building systems which would be, uh, which would fit into this matrix of power, price eventually, and performance.
Got it.
And also size matters.
True.
For the modular design, if the size is so big, then how do you integrate it, right?
Exactly.
So
They have a very, nomenclature of PPA,
Yeah.
price performance in area.
Yeah.
So that's what the designers look at.
Right.
When you are hiring talent, right? would you like somebody who has spent say 5-6 years in in semiconductor electronics and is kind of outdated? Would you like that person, and then kind of reskill and upskill, like what TCS is doing today, saying that 100% of their workforce is AI trained? I don't know what that means. And or else would you rather have somebody fresh who does not have any preconceived notions about the industry and train them? What is your perfect bet?
If you specifically ask me, I wouldn't take either of them. Neither freshers, neither experienced. We need people who could learn and who have basic ideas at least, because you cannot bring in an honors guy and start showing him about semiconductors and start training him about semiconductors. It's not possible. We need people who have basic idea about electronics. We need people who have basic idea about starting the alphabet. They know the alphabet of semiconductors. These are the people whom we need, whom we can train on. And also it's about learning capabilities, right? People whom we are taking in, they have to adapt to newer technologies every single day, because the way we are growing in semiconductor is too fast. I wouldn't hire a really expert guy into certain positions, because I'm sure I need to achieve newer goals rather than going back and sticking back to the loop. But whereas in certain positions, if it's like, let's say if it is in fab design and other things, I would definitely say I would go for an experienced guy. But in the state that we are in at Ridex, I'm not going for neither expert, neither fresher. I need someone who has basics of understanding. Then I would bring in an expert and get him trained.
Got it.